Hello guys, welcome back to the Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. In today's lecture, we are going to explain the difference between the tensile strength and the compressive strength. So how we can differentiate between these two types of the strength, and they are very important in civil engineering because they are mostly common used in the in design principles of the engineering design. For example, I will consider these two objects. For example, this is a one object. It might be steel bar, or it might be any aluminium bar, or maybe any other kind of material. But I would like to explain here that what is tensile strength we can define here on this material. So the object is considered here, for example, is a steel, and when the load is applied here on both sides here in this direction and also in this direction, which expand the object, so this load will be known as the tensile load. For example, this is P and here is P. So now because of this load, the object will try to expand. So if I draw the new shape, for example, if I draw now the new shape of this object, so how it will look like, the new shape will be expanded. It will stretch in lateral direction and it will expand in the horizontal or longitudinal direction. So now we see that there is some expansion in this object, which is, I define it as a delta. So due to this, due to this tensile load P, there will be some resistance load created in this object in order to resist this tension. So these are known as this tensile load which is created inside this object, which will be equal to the P. This will also be equal to the P magnitude because it will resist this applied load. So this will be same in magnitude and it will try to resist the load which is applied on this object. So now the resistance created in this object will be known as the tensile strength of this material, or tensile load here, tensile load resistance. But how we can define the tensile strength? So the tensile strength is basically, tensile strength will be equal to the tensile load which is created because of this object dividing by the area on which this load is acting. So it will be equal to the P, which is this P. Keep in mind, it is the tensile resistance, tensile load resistance P divided by the area. Now, for example, the load created here is 5 kilonewton, and this one is also 5 kilonewton. So it means the resistance will also be 5 kilonewton, and this resistance will also be 5 kilonewton. So our load resistance for tensile strength, our load resistance is 5 kilonewton dividing by the area of the object. Now the area, the surface area of this object on which it is acting, for example, this area of the object is, cross-sectional area is, let's suppose, is 2 millimeter square. So the area will be 2 millimeter square. So if we divide this, we got 2.5 kilonewton per millimeter square. So now this is known as the tensile strength of this material, that it can resist this amount of the load, because after this load the material will break. So this is known as the tensile strength of the material. Now how we can define the compressive strength? It is opposite to that of the tensile load. How? For example, if we again apply the load, here, P, C, compression now, C, because in compression the load will try to compress the object. Compressive strength means the load will be applied in order to compress the object. So what will happen? The object will be expanded in the lateral direction and it will contract in the longitudinal direction. So there will be a delta again here, and this is now compression delta because they are compressed. So now because of this, there will be again stresses generated, and this will try to resist this load, C, compression. Compression C, for example, I presented it by CA and CA. So this CA will be equal to the C magnitude. The magnitude will be the same because the stresses are created inside the material in order to resist this load. And how we can find the compressive strength now? It will be equal to the compressive load divided by the area. Now compressive load is C which is equal to the CA dividing by the area of the material or the object. So if we take, for example, that the load that this material can take is, for example, this load is, for example, 10 kilonewton, and after this load the material breaks in compression. So this is the maximum applied load. So it is C is 10 kilonewton. So compressive strength will be equal to the 10 kilonewton divided by the area of the object. For example, is cross-sectional area is 5 millimeters square. So divide this by 5. So we come out to be 2 kilonewton per millimeter square. So this is the compressive strength of the material. Hope you guys understand the main difference between the compressive and tensile strength, and don't forget to subscribe our channel for daily civil engineering videos.